Greeting guys, my name is Pamela Lozoma. Here today I'm going to talk about graph algorithm which you use in data science. Graph algorithm has three aspects, which is directed graph, undirected graph, and cyclic graph. A directed graph has a node which is known as a vector, a vector which is also known as the destination from and to. And it also has an edge which is a connection. So, uh, okay, we move to an undirected graph. An undirected graph also has a node and an edge. The thing that's special about an undirected graph, uh, it can also be a cyclic graph. Here's an example of a directed graph. Here's a node. Here's our edge, the connection. So the directed graph has a node, destination, from and to, from and to, from and to, from and to. So here it has a destination from Devon to GHP, from GHP to CT, from CT to Devon. This is an example of an undirected graph. An undirected graph, you can spot it by having, it has a node from, to, and back. An undirected graph can be also known as a cyclic graph because there's an endless loop here. This part is known as a directed graph, and a directed graph here, this part is known as an undirected graph or a cyclic graph. So we move to top. There's a thing that we use in data science which is top, down, left, right. So here is an example of a graph algorithm where we have numbers from 1 to 8. So 1, 2, 3, 4, 5, 6, 7, 8. Let me fix here. Okay. Here's it. So when we try to spot graph algorithm, we move from top to left, top, left, down. Here's it. So it's gonna be top, left, down, top, left, down. Okay, here 1 is connected to 2 and 2 is connected to 4. We move to 2. 2 is connected to 4, then 2 is connected to 2 is connected to 3, then 2 is connected to 4, then 2 is also connected to 7. Here 3 doesn't have a connection. 4 has a connection of 7, then 4 has a connection of 6. We move again. Here 5 has a connection with 8. 5 has a connection with 8. Then 5 has a connection with 7. Yeah, these at the bottom doesn't have any connection. There's also a thing that we call an adjacent list. An adjacent list is where we check the connections of our graph algorithm. So please give me a minute because I didn't write that down. Here's an example of an adjacent list. As I said, 1 is connected to 2 and 1 is connected to 4. 2 is connected to 7, then 2 is connected to 4, then 2 is connected to 2 is connected to 3, then 2 is connected to 4, then 2 is connected to 7, 4 is connected to 5, then 4 is connected to 6, 4 is also connected to 7, then 5 is connected to 6, then 5 is connected to 8, as you can see right here. If we move along, there's a thing that we use in machine learning. In machine learning, our computer only understands 0 and 1. If our node is not connected to the other node, we write 0. If it is connected, we write 1. Here's an example. Don't know if you can see clearly. See here, 1 is not connected to 1, so we write 0. But 1 is connected to 2, so we write 1. The list goes on. Okay. So now we move to binary tree. Binary tree reuse zeros and 1, which is machine learning. The characteristics of a binary tree: it must have a root, a branch, and a leaf, and it is doesn't have a loop. So here's an example of a binary tree. We are given here 7, 1, 4, 7, 1, 10, 20, 50, 1, 3, 7, 8, 2. So here is our binary tree. At the top must be a root. Then we use the left, top down, right, left, right function. So here is it. 7 at the top, 1 at the bottom, then 10. 10 give birth to O. Then 1 gives birth to 20, then 50, then 10 gives birth to 1, then 1 gives birth to 3. Then 20 gives birth to 7, then 20 also gives birth to 8, then 50 gives birth to 2. The last one, it must be our leaf. Okay. Here, 7 is our root, then 7 can also be our branch. 1, 10, 20, 50 are also our branches. The leaves are the last one, the last tree, because it doesn't have any branches, which we call it our leaves. So 7, 8, and 2 is our leaf. Okay. When we use an binary tree, we also use an heapyfication. An heapyfication helps us to store our data correctly. And hyperfication has max heap, min heap. Yeah. When you use max heap, starts from the last leaf, which here is 2. Okay. So here is an example. Here is an example of a max heap. We check. Okay. We check the last branch, which is 50. If it is greater than 1, if it is greater than 1, then we move it to the top. Then 1 comes down. Then we check 50. If it's greater than 7, then yes, it's greater than 7. So 50 move to the top, then 7 move down. Here it is, here on my left. See here, starts at 50, then has 7, 10 didn't change, 1 change, then 2 didn't change because it's our last leaf. Okay, so we must write down every heap that we got. So we move along. So if we take down 50, we are left with if we take down to 50, we take the last leaf at the top. So we're gonna check if 20, we're gonna start at the last leaf, which is 8. Gonna check if 20 is greater than 7, which is greater than 7. 20 is greater than 7, so 20 will move up, then 7 will move down. Here we have 20, then here we have 7. So gonna check again if 20 is greater than 2, which is true, then 20 move up, then 2 move down. Here's don't know guys if you can see here's the solved heap. So we're gonna write down 20 again. Move along. Yeah, basically guys, you're gonna do the same thing in the main heap, which is 7 at the top, which is our roots, then 2, which is our last leaf. Here we check if 2 as our last leaf is smaller than 50, which is true. Then we take 2 up swipe it with 50. Then we continue to check if 7 is less than 20. 20, which is true. Then we swipe. After we swiped, then we check if 1 is less than 10, which is true. Then we swipe 1 and 10 here. Okay, we move along. We're gonna check this one if it's less than 7, which is true. So we swipe it just like this. So 1 comes at the top, 7 goes to the bottom. So here we have our main heap. So we're gonna check if 2 is less than 7, which is true. So we're gonna swipe them just like this. This is a final min heap. So at the top as our root, we have 2, then we have 1, then we have 2 at the right, at the left, then 1 at the right. It has branches of 7 and 7. 7 also have a branch of 20 and 8. 7 also have a branch of 50. 28, 50 our leaves. Then 1 has a branch of 10 and also 3. 10 and 3 is also our leaf because it doesn't have any branches on it. So the main heap has an array of 1, 2, 1, 7, 7, 10, 3, 20, 8, and 50. So we also have a decision tree. A decision tree must have a root, a branch, and a leaf. But here, which is special, a branch cannot be a root, as we've seen before. We use clarification, where we use 1 and 0 to determine strings. And we also use regression analysis, which is a continuous value where you check numbers. Okay. So here we have a database whereby we have student ID, students in library, student that live in campus, student that attend extra classes, student that attends evening classes. So in student 1, all of the above are yes. In student 2, student 2 doesn't studies in library but live in campus, doesn't attend extra classes, doesn't attend evening classes. Student 3 studies in library, doesn't live in campus, attends extra classes, and attend evening classes. Student 4 does not study in library, does not live in campus, does not attend extra classes, and does not attend evening classes. Student 5 studies in library, live in campus, does not attend extra classes, but attend evening classes. Student 6 does not study in library, but live in campus, also attend extra classes, but does not attend evening classes. Student 7 studies in library, does not live in campus, does not attend extra classes, and does not attend tutorials. So our main targets here to our database, our main focus is here, attending evening classes, even though we didn't get the scenario of what we are looking for. It may differ, but most of the time our main target is found at the end, but it can also found in the middle of our database. So a decision tree is more like a binary tree, but it is different because gonna check if students, you're gonna check the purity and impure of our, you're gonna check if which one is our roots here. So gonna check starts with students that study in library. So we have three students. We have four students that study in library. So our branch of 4 years, we have four in total. For our no, we have three because in total there are 7 students. So we're gonna break it down bit by bit. So in our branch, student that attends tutorials, there are 3. That doesn't 1. On another branch, we have a leave for yes. Our leave, because as I said, our main target is evening classes. So student that studies in library attend extra tutorial, there are 2. And student that studies in library attend doesn't attend tutorials but attend evening classes, there are 0. So we move to our no branch. You're gonna check students that study in library. Okay. Before we move to the student that doesn't study in library, let's continue with student that studies in library, attend extra classes, that live in campus. There are only 2 students that have a such condition. So student that study in library, attend extra classes, live in campus. There's only 1 yes and 1 no. Then we have our leave for yes that attend extra classes, which is 1, and does not attend extra classes, which is 0, and the student that studies in library, attend extra classes, and lives on campus. For leave no, we also have 1 and 0 yes. Move along to students studying in library with that doesn't study in library to a leave no. So we have 3 students that doesn't attend extra classes but studies in library, and we have 0 students. Move along to node by node, yes no breakdown. Here gonna have 1, 2, 3, 4, 5, 6. We're gonna move to purity and impurity. Yeah, Here we have a not, a yes condition, a no condition, total, entropy, status. Here, gonna start with our roots. Our roots must have all the data. So in yes, we have students, the studies, wait, we have students that attends evening classes, which are 3, and 4 no's. In total, there are 7. In trophy, gonna explain that as time goes on. And our state has most impure. Students that studies yes branch, we have 3 yes and 1 no. In total is 4. In trophy, it is 0,811, which is impure. And student that studies in library, which is a no leaf, we have 0 yes, 3 no, and 3 total. Our entropy is 0,000, which is pure. Student that attends extra classes, yes leave, have 2 yes and 0 no, and 2 in total. So our entropy is 0,000, which is pure yes. And we also have a tutorial no branch, where we have 1 no and 1 yes. In total, there are 2. I think I make a mistake. So our entropy here is 1,000. Our status is most impure. Tutorials, student does not attend tutorials but live on campus branch. We have only 1 student who said yes and 0 student who said no. In total is 1. So our entropy is 0,000. Our status is pure yes. And we'll check our last condition of a student that doesn't attend extra classes and doesn't live on campus. We have a 0 student that said yes and 1 student that said no. In total, there's 1. So our entropy is 0,000. And if we check our status, it's no. Thanks for watching. Catch you on another video.